All right, welcome everybody to week 9, day 1. We're going to be learning 2 new data structures today. We're going to be learning queues and stacks. These are 2 fundamental data structures that are taught everywhere in the nation in a first year data structures class. And the good news is they're actually really easy to learn. You might be like, oh, but we've been spending weeks on linked list and all the pointer stuff and all that stuff. Stacks and queues are really easy. So let's just show you what it looks like to do a queue. Okay, so a queue is what's called a FIFO data structure. A FIFO data structure means first in, first out. Conceptually, you can think of a queue as like a line at the grocery store or a line at the bank. If you are the first person to get in line at the grocery store, you're the first person to get called forward when the clerk is ready for you. And if they're not ready for you yet, then a person will queue up behind you, hence the name. Then a person will queue up behind them, and a person will queue up behind them. And then the grocery store clerk will call a person forward, and they pop off the front of the queue. They push into the back of the queue. In other words, you add people to the back of the queue, and you pop people, you take people out of the queue from the front. So if you guys remember going to movie theaters in the before times, people used to line up at a movie theater, and when a ticket window is open, they'd call you forward, and you pop off the front of the line, and they help you, and you leave, and people line up at the back. So here we got an empty line. Queue is empty. And the person 1 walks forward. That's a push operation. Push means add somebody to the queue. And then person 2 walks up. And they push into the back of the queue. And then you push again, and they come into the back of the queue as well. And then when you pop, they pop off the front. And so after you've had 3 people in line, 1, 2, and 3, when the teller calls somebody forward, person 1 leaves the queue. And so you've got person 2 and 3 in the queue right here. Then person 4 walks up, then person 2 gets called forward, and you're left with 3 and 4 in the queue. Then person 3 gets called forward, there's person 4 in the queue, then person 4 gets called forward, and the queue is now empty. You got an open lane at the grocery store, which is always one of those things that makes people happy in life. One of the worst things where like every single line is just 7 people, like on Thanksgiving or something like that. It's the absolute worst. So this is called first in, first out. The first person to join the line is the first person called forward. And that's about all there is to it. There's only 4 operations you can do on a queue. Add somebody to the end, delete somebody from the front, check who's in front. Like if we asked right here, hey, who's in front? That's called front. It's literally the name of the function in the standard library, front, who's in front of the queue. It would be like 2 is. You're like, okay, cool. And then size. How many people are in the queue? Now, 3 at this point in time where my mouse is. Now, there's a problem with the queue class in the standard library, which is that it's that's it. That's literally the whole thing. And it implements this notion of a queue very, very nicely. But sometimes you want to know who's in the middle of the queue. Like, for example, if you wanted to print everybody in a queue, which is something you do, right? When you're writing code and you're like writing like code to handle, I don't know, like grocery store lines or something like that, a lot of times you want to like debug it and like, all right, give me a list of who's in the queue right now. And it's like, all right, first up is Mrs. Grundle, and second up is, Mr. Jack, and, in the back there is, so-and-so, and you can't do that actually with a queue. If you try making a queue in C++, if you make like a queue of integers named queue, you could do like q dot push 1, 2, 3, q dot cout, q dot front. That tells you who's at the front of the queue. So if I've done this right now, push 1, push 2, push 3, which one of those 3 numbers is at the front of the queue? What's it going to print there? What do you guys think? Got a 3 from Otal. We got a 1 from everybody else. Who was the first person we added? 1. So person 1 is at the front of the queue. Okay. So they rolled up first, they rolled up second, they rolled up third. So the queue is currently 1, 2, and 3. However, all you can do is print the front. There is no like dot at. Like you can't say q dot at, you know, anything. So it's too limited to be used. So typically what we do instead, if you're going to use a queue, we typically will use a list. And then you can do, you know, your standard range-based for loop, right? For auto. Push back. On a list, it's called push back. And then we get 1, 2, 3 in order. So a list can be used actually to implement a queue. It can also be used to implement a stack if you want. And in fact, that's what we're going to do for our coding competition today. So make sure you understand conceptually how a stack and a queue operate, because you're going to be doing it today. All right. Can you for loop through it? Nope. Let me switch back to a queue here. 5x, 5x. I can't do it. That's why I consider stacks and queues useless. Instead, I just use a list, or I use a deque, which is another standard library data structure you can use to implement them. So yeah, they're very limited. Why are they in the standard at all? Presumably because every data structures class teaches stacks and queues, and they just wanted it in there for completeness sake, even though nobody, like, non-ironically, I've never used a stack or a queue. Like ever. Like I might have made it to like experiment with it, or like, see if I could do a range-based for loop on it. But like an actual professional practice, I've literally never needed to use one, because they're just like a list but worse, or a deque but worse. So now, how do we delete from the front? We can do q dot pop. Deletes the first person in the queue. So who is the front of the queue now? Person 1 went up, person 2 went up, person 3 went up, person 1 gets called forward. Who's at the head of the line now? 2. Yep. So 2 is at the front of the line. And that's it. You got push, pop, and top, and size. Right? You can see out the size. Q.size, and that's really about all you can do with a queue. It's got a size of 2. There's 2 people left, the 2 and the 3. Any questions about that? Like, is that it? Yep, that's it. That's it. There's some obvious questions here, but I'll see if you guys can come up with them. I see typing. How do you access the middle of the queue? You can't. Or technically, you can just pop everything off the queue and then add the elements as you pop them to another queue, and then you could get the middle of the queue that way. But it's garbage to do that, right? Like if you have 100 people in line, you could pop them all off one at a time, and as you pop them off, you add them to another queue, and then when you get to the middle, you're like, aha, there you are, and and then yeah. Just use a list. You need to do that. There is no back. There's only front, I think. So there is no dot at. Yeah, that's why I'm saying it's too limited. Like you can't loop over it. You can't. There's push and pop and top and size. That's it. That's the entire class. What happens if you try to print the front of an empty queue? Great question. Also not the question I was expecting, but it's a good question nonetheless. We got a 0 here. I think it's actually undefined behavior. Let's see. out of bounds. That's actually CPP check that found that. So yay, you go Google CPP check. You found an empty. Let's see if we can fool it a little bit here. Pop, pop, pop. Good, we fooled it. All right, and so the this is using the safe standard library. So the safe standard library does bounds checking, and so it actually checks to make sure there's something in it, and if there's nothing in it, it seg faults. If you use the regular standard library, it's undefined behavior. I've had it seg fault before, so you have to be very careful not to pop from an empty stack or queue. You have to be careful not to top the top of a empty stack or queue. Okay, so the obvious question is like, why would you use this? You know, and the answer is first of all, you would not use the queue class unless you wanted to be in like hard mode. So some people are doing Hogwarts Legacy right now, like they're doing what's called a Muggle run, where they're like killing everybody with like cabbages and stuff like that, like no spells, like the no spell challenge in Hogwarts Legacy. It's just like a voluntary restriction, right? Of just like, we're just not going to cast spells except where necessary to advance the plot. That's queues, right? It's just like you've got a list and then you're just like not going to use some of the abilities of it. And some people like that. They like the design of this. Like, you can't trust me with all that power. I might add to the front of the queue. If you give me the power, I might add to the front of the queue. And with the queue class, you can't do that. You have no ability to add people at the front of the line, only at the back of the line. You have no ability to, print out everybody in line, because that violates the queue class invariant. And so you're sort of voluntarily accepting less power, like a voluntary challenge in a video game or something like that. And some people do that for like safety reasons. Like, what if I accidentally did push at the front of the line? All chaos will break out. For fun, yeah. Or like a vegetarian run or something like that, where like you play a video game without eating any meat in it. Like Valheim with no meat. Good luck. Have fun with that. Okay, so that's a queue. Now, a queue, again, is called FIFO. It's the first in, first out principle. So do you guys see how that works? Like the first person to join the line of the bank is the first person to get called forward. Makes sense, right? Have you guys played the world's where is there you go. So you'll see FIFO used in computer science like terminology all the time. And so the obvious question is like, when would you use like a queue? Like just not the queue class, but like when would you use a queue? Like just, even if you implement it using a list or something or a deck, when would you use a queue? And the answer is you use queues all the time, actually. Anytime you have an asynchronous producer and consumer, anytime you have somebody producing data and somebody consuming the data, like let's say a keyboard, right? You can sit there and type on your keyboard. Have you guys ever like lagged out in like Microsoft Word, where like you're typing and like Microsoft Word just like, just like freezes for a second, and then you're typing, and then like a second later, Windows is like, hey, Word, get back to work, and then it's like, and then like your letters appear a second ago. There's a FIFO for your keys. It's a queue. It's like as you type, the operating system is placing all of your keystrokes into a queue. And then when Microsoft Word is ready for them, it pulls the keys out of the input buffer. And so you'll hear these things called buffers as well. So where's my mouse? Okay. Buffer. And anytime you have that, like if you have a network and you have data is coming in for World of Warcraft, the operating system will put all of the incoming data from the World of Warcraft servers into a buffer. And then when World of Warcraft is ready for reading from the network card, it reads out of the buffer. And so you have data flowing into the buffer in the back. So like new data is like joining the back of the buffer. And then when, World of Warcraft's ready to read it, it pulls stuff out of the front of the buffer. And so it's constantly like reading from the front, and the network's coming in the back. And that's how networking works. Anytime you have asymmetrical production and consumption, you typically will stick a FIFO or a buffer, in other words, in between the source and the destination. You guys understand? Because otherwise, World of Warcraft itself would have to like pause, you know, until the data comes in. It's like how your brain works. It's funny. So that's kind of the main use, and these things pop up everywhere. You'll hear somebody say, "Oh, stick a FIFO between the two things," and everybody knows what it means. It's a very simple data structure, and that's about all we have to say about queues. Okay. So next up, we have stacks. Yes, we are doing 2 data structures in one day, and stacks are very, very similar to queues, except they are not first in, first out. They are LIFO. Last in is first out. So imagine you're at like a buffet. Have you guys ever been to a buffet before? Where they have like the stacks of plates as you like walk in, like you take a plate off the top of the stack, literally a stack. There used to be a place called, what was it called? Like Fresh Tomatoes or like Ripe Tomatoes. It's like a buffet on like Herndon and Fresno, something like that. Ripe tomatoes, fresh tomatoes, sweet tomatoes. Yeah. I love that place. It's out of business now, unfortunately. So yeah, you'd walk in and like you take your plate off the top. And then like when the people do dishes, they clean them and then they put them back on top. So every time an employee drops a plate, oh, it's doing this thing again. Stop. Yeah. Nope, mouse. I'm not even hitting it. I'm not even touching it to the thing. There we go. All right. So when the employee comes in, they add a new plate to the top of the plates, right? And then a customer comes in and takes a plate off, and then the employee washes into their dish and puts it back on top. And then an employee is like getting frustrated, but you know, whatever. And then a customer takes a plate off, and a customer takes a plate off, and a customer takes a plate off. Now the guy's like, I gotta wash even more. You know, do you guys understand? Or like a stack of pancakes, like, you know, you take the top. No, you eat all the pancakes at the same time. A stack of pancakes is a bad metaphor because I just like cut right through them and just eat like, you know, 3 pancakes in one go. Yeah, but like the plates at a buffet is a good example. Another example would be your fridge, right? So if you've ever used a fridge, right, you got new groceries coming in, you got like a jug of milk, you just stuff it right in the front of the fridge, right? And then everything behind the jug slides to the back of the fridge, right? And then you get like a thing of orange juice. You just shove it in, and then the milk slides to the back, and the orange juice is in front. And then when you want to drink something, you take the orange juice out first, and then you take the milk out, and then you take out the yogurt that's been sitting in the back of the fridge for 3 years, right? I'm joking. I don't do that, Megan. Yeah. So, but like, yeah, when you have a fridge, you have to rotate it exactly because it's a stack. If you have new products coming into the front, and then they leave from the front, then what happens is that all the stuff in the back goes stale. That's exactly the problem, Megan. It's normally a stack system. If you've got like a rack of bottles of water, and you shove a new one in the front, and then you take things out the front, the things in the back will sit there for ages, right? So you have to rotate your product, or the stuff in the back will go stale and rot. Now at a grocery store, is it a stack or a queue? Have you guys ever seen the fridges at a grocery store? So like when you're at a grocery store, let's see if I can draw this. The milk is on like a rail like this, right? It's a queue. Yeah, exactly. And so the employee is like sitting back here, and they like add new bottles of milk to the back here. And then the customer, this is the front door, then a customer takes the milk out this way, right? And so it is a queue, not a stack. Your normal fridges are a stack. If you just have a cooler or something like that, you know, you got rails on it, you stack them in. and then people pull off the front, and you stack them into the front, and they pull off the front. A grocery store fridge, though, loads from the back. So you push it in the back, and you pop off the front. So home fridge, stack. Grocery store fridge, queue. Okay. I used to hate going and finding out that no one had rotated the prep. Yeah. One of my former students worked at Smart and Final or like a dollar store or something like that. And like they never rotated their product. And so they would find yogurt covered strawberries that was they weren't, it wasn't yogurt. It was it looked like it was strawberries coated in yogurt, but they were just strawberries that had been there for a really long time. Yeah. So yeah, rotating your products is important for that reason. Okay. So yeah, that's a stack. And so what's used for a stack? The most obvious use is the stack in computer science. So you've got main up here, and main's got some variables x, y, and z. And then when main calls a function called foo, the stack moves down and it makes the variables for foo, maybe a, b, and c. And then foo calls a function called bar, and the stack moves down, and you've got functions z and a and q or something like that. And then when the function returns, the stack moves back up, and then these variables are still there. And then when that returns, the stack moves back up, and these variables are still there. And so the whole way that we do regular variables, like int x and things like that, that's all held in a stack. So that's a stack. It's very similar to a queue, except you push. Well, it's not the front. Stacks we think of as vertical. Queues we think of as horizontal. I don't know why. Yeah, a stack you push and pop off the top. Whereas with a queue, you push in the back and pop off the front. Okay. So if we want to do this in color sorting of these stacks, such a nice time killer. Yeah, there's Towers of Hanoi and things like that. That's a stack, essentially. So let me show you guys how to do a stack in C++. Stack of integers named S. Let's do all this. Okay, so S dot push 10, and we need to include stack. Cool. All right, cool. So push 10, 20, 30, and we see out S dot top. It's not S dot front, it's S dot top, because we think of stacks as being vertical. So what value is this going to print? We've pushed, like imagine we got plates, and we have a plate, and we write the number 10 on it, and we add it to the bottom of the thing. We get a plate called 20, and add it on top of 10. And then we take a plate and write 30 on it, and add it on top of the 20. Which one's on top? 30, very good. And then if we do a cout S dot size, how many elements are in this stack right now? So there's only 4 operations, right? There's push, pop, and size. That's really it. That's really about it. And if you want to print out all the elements in the stack, sucks for you. Use a list instead. 3. Yeah, good. And then if we do S dot pop, who's on top now? Zero, 2, 20. What was the ding for? Everybody getting it right? Yep. So 30 on top. Then it's true though. Like you yeah, if you want to print all the elements in the stack, it's like you can't. I guess you can pop things off one at a time and destroy the stack and then push it back on afterwards. It's just so inconvenient. Like it's just yeah, stack and queue. I don't use it. Instead, I'll do something like this. Like I'll make a list instead and say push front, and then that'll be the front, and then pop front. And that will be front also. Girlfriend not found. And so you can see I get the exact same answers as for a stack, but because I'm using a list, I can actually enumerate all the elements in it. I could say for int I in x and stack cout x, and I can actually just print out all the elements 30, 20, 10, right? Easy, right? So the stack class and the queue class exist, I think, for completeness sakes. I would never use them in an actual C++ program unless you just want the voluntary limitation of having a data structure that's a list that does less. Okay. What if you made a duplicate stack and destroyed the stack? You could. It's absolutely horrible. Or you can take all the plates off, right, and print them out as you take them off, and then if you put them all back on, then you end up with the same stack as before, but you're so, you have to destroy the stack to print the stack. It's like no, I don't want to deal with that. You can also use a vector for a stack as well. So you do vector, and then we do push CW and back. And then this would be back. That. And we get the same answers again, except this time it's in reverse order because we're doing push back instead of push front. Okay. But all the pushing and the popping and things like that, it basically, you can use a vector to do a stack as well. You just push and you always push and pop off the back. You can't really use a vector to do a queue because what's the problem with deleting from the front of a vector? Pushing at the back of the vector is no problem. We do push back all the time. You guys all know this. Push back, push back, push back. What's the problem with deleting off the front of a vector? Order in, exactly. So we want it to be order 1. We want to be able to delete something in one operation. Instead with the vector, we'd be doing in operations to delete it, and that's no bueno. So if you wanted to use a queue, if you want to do a queue with a vector, it's terrible. You can't, don't do it. But there is a data structure called a deque, and a deque not a queue, sorry. Typing and talking at the same time. Okay. So a deque has the ability to push and pop off both sides, like a list. So you can push back and pop back. And so push back and then pop front. So the deque, we're adding 10, 20, 30. We're making a queue now. 10, 20, 30 comes to the end of the line. We print out the whole thing. We then print the first person in line. What is this going to print? We added 10 first, then 20, then 30. Who's front in line? 10. Good. We print out the size, get 3. We pop the first person off, so 10 gets handled by the teller. Who's front in line now? 20. Good. Yeah, conceptually, not too bad. So, your challenge for today, if I can become somebody, Otal maybe, no, Tipton maybe. You'll see that there is now a folder here called Coding Competition Queues and Stacks. And this is what your job is for today. So, you should be able to, by the end of today, by the end of class today, be able to make a queue class and a stack class using the power of std::list. Okay? So this is the std list class, okay? You don't have to make your own list class until part 2. For the first part, you just use the standard library list class. And so you're going to implement a queue class and you're going to implement a stack class. And each one of these things is going to be roughly 1 line of code, right? So if you want to find out how many things you have in your queue, you would just return my data dot size. There you go. Because you're using one data structure to implement another data structure. If you're like, well, that's cheating, guess how the standard library does it. The standard library makes the queue. They didn't make a queue class, and they didn't make a stack class either. They used, I think, the deque class, if I'm remembering correctly, or maybe the vector, maybe vector for stacks. I don't know. It's actually, I don't even know if it's in the standard which one they have to use under the hood. But if I had to do it, I would use a deque for the queue class, and I would use a vector for the stack class, and just basically do this. And so they make a new data structure using an old data structure. This is an acceptable technique, and this is what you're going to be doing for the coding competition today. So how do you get the front of a list? So we're implementing a queue, and you're writing a function that is going to return who's the first guy in the queue. How do we get that from our list? What's the name of the function to get the front of a list? .at. There is no .at with a list. Lists do not have random access, so there is no square brackets, and there is no .at with a list. Yep, it is called front. So you're just going to return my data dot front. Okay. And so for pop, I'll let you guys figure out how to pop from the front using a linked list, and how to push at the back of a linked list. Okay. Each of these is going to be about a line of code. There's a die function up here, and you die if you try to delete from an empty list, or if you try to print the value at the front of a. So for front and for pop, add a little error checking. If the size is 0, then die. Okay. Size, you can return a size of 0, so you don't die on that one. And obviously you can push on a size 0 queue. But for front and pop, die if you try deleting elements that aren't there, or if you try printing the value of something that isn't there. Okay? So you guys got till the end of class to do this. The queue class is already half done. I don't know. Is this too hard for you guys or too easy? What do you think? Don't say it's too easy. It's both too easy and too hard? Okay. So hard. Okay, well, for those of you that are worried about it being too easy, what you're going to do after you get these things working, you're going to pass all your test cases. Then, instead of using std_list, the standard library list function, you are going to make a linked list class using the code that we've done before. So where it says you'll be doing something here after you finish part 1, you're going to make a list class, and all you're going to do is just substitute out like that. Okay? And use your list class with your push front and pop front and push back and pop back for the remaining 5 points on the assignment. Okay? So 5 points should be doable in about, I don't want to say 5 minutes, but like by the end of class today, you should be able to have a line of code in each one of these slots here. Okay. And add the error checking on front and pop, die if it's empty. And then you have till Friday to write your own list class, and the list class needs to have these 5 functions on it. Push front, push back. Doesn't need pop back technically, because neither stack nor queue uses pop back. Queues push at the back, but they pop off the front, and stacks push and pop off the front, so you don't actually need a pop back. You can write one if you want. And you only need front and size. So who's that head and things like that. So this class, we've been doing a lot of practice with linked lists and trying to give you a lot of exposure to it in different ways, because what I do is I monitor how students are doing, and you guys aren't doing well on linked lists. That's why we haven't had the competency exam yet on it, because I feel like you guys need more practice with it. So basically, we're going to keep doing linked lists in different ways like this. We're still moving on. We're learning stacks and queues, but we're still practicing linked lists. And we're going to keep doing this until I feel that the class is reasonably confident at working with pointers and linked lists and things like that. Or we run out of time in the semester, one or the other. Okay. Because if you can't do linked lists, you can't do binary search trees. Because binary search trees is the next data structure. And it's like a linked list, but with 2 pointers instead of 1. I mean, technically a doubly linked list is 2 pointers. It's like a linked list where every node has 2 nodes after it instead of 1 node after it. There, a little preview for what's coming up. Okay, and then the main is already done for you. So it's going to read in data. I kind of made a mistake on this. There's no actual quit. There's no option to quit. And so you quit by just typing in like a number that's not 1 to 5, and we'll print bad input every time. Oh well, it's not the end of the world. It'll just, yeah. Every program will end with bad input. Oh well. I coded this in like 10 minutes in the class today. All right, any questions about this? What's the competition part? The competition is you're going to try and get the first half done by today. End of today. Okay. And is it worth extra credit? No. I probably should have. Given that to the 12 o'clock students. Huh? That was the intention, but I kind of forgot to mention it. So, no, unfortunately not. But it's a challenge to see if you can get it done in half an hour or so. All right, I'm going to stop the recording now.